So, real quickly, this first lesson, 113, like I said, it's got algebra and geometry, the relationship between those. Specifically, you're going to be looking at perimeter and area of different figures. So just a quick heads up, what is perimeter? How would you describe it? Yeah, all the way around whatever the shape is. Outside. It's a length, okay? So when you talk about units as well, it's just a length, centimeters, inches, feet, whatever it happens to be in, okay? What about area? How would you describe that? Yeah, it's inside whatever shape, okay? It's the inside part of it. If you think about the floor, for example, somebody had to come in when this building was built and tile the floor. That's the idea of the area. Perimeter would be kind of like this stuff that's going around the outside. That's the perimeter of this room, okay? So perimeter and area are going to be the main concepts from today. And as you take a look, here's the actual lesson, and I'll give you this shortly. I'll give you the actual what you're going to work off of. But we're going to talk about predictions, okay? And the idea today is you're going to look at a pattern, find the perimeter and area of those patterns, and then try to come up with an equation that fits that pattern, so that ultimately we can make a prediction. And that very honestly is what math is all about in real life. Regardless of what you go into, that's where people use math in real life. If you think about it like a financial planner or something along those lines, I'm just picking a random job. Their job is they look at the stock market, they look for patterns, and then they try to advise you with your money. I think you should put it here, I think you should put it there, so you can make the most money possible. They're not always right, okay? Think about a weatherman. They're definitely not always right, but they're basing stuff off of math, and they're making predictions based on what they see. That's what we're looking at today, okay? So if you notice, one of the core areas of geometry is measurement of shapes. Often in this course, it'll be important to find areas and perimeters. How these measurements change as a shape is enlarged or reduced in size is especially interesting. Today, your team is going to apply algebraic skills as you investigate the areas and perimeters of similar shapes. So here's the actual problem, and then I'm going to get you going and have you start working. So, Carpetmore here. Your friend Alonzo has come to your team for help. His family owns a rug manufacturing company, which is famous for its unique and versatile designs. One of the most popular designs is shown at the right. Each rug has an original size as well as enlargements that are exactly the same shape, just however many times bigger, okay? Alonzo is excited because his family found out that the king of a far, far away land is going to order an extremely large rug for one of his immense banquet halls. Unfortunately, the king is fickle and will not decide which rug he's going to order until the very last minute. Where I lost my place. The day before the banquet, the king will tell Alonzo which rug he wants and how big it needs to be. The king's palace is huge, so the rug is going to be very big. Since rugs are different sizes, since each rug requires wool for the interior and fringe to wrap around the outside, right there's your perimeter and area. Okay, so the wool is the interior. There's your area. How much wool do we need? And the fringe around the outside, there's your perimeter. Okay, there's your geometric concepts. Alonzo will need to quickly find the area and perimeter of each rug in order to obtain the correct quantities. Here's your task. Your teacher will assign your team one of the rug designs to investigate, labeled A through F. I'll show you that in a second. Like I said, I'll get you the packet here in just a second. I'm going to have you work off of. The original rug is shown in Figure 1, while Figures 2 and 3 are the next enlarged rugs of the series. With your team, you're going to create a table, a graph, an equation for both the area and the perimeter. Okay? Now, there's 6 different ones. You're just going to have to do one of them as a group. Okay? Be ready to share your analysis with the rest of the class. About 10 minutes left in the class, I'm going to kind of bring you back together, and we're going to just kind of go over some things so that you can understand, and I'll have you share what you found, and I'll have you kind of share out a few different things. So you're going to be looking at those different patterns. Here's the different rug designs. You can kind of take a look at those while I hand out the packets that you're going to use today. Let's see. Here we go. You might want a calculator. So either a calculator or if you want to do it on your iPad, that's perfectly fine as well. Remember, if you're going to do it on your iPad, I would suggest if you don't already have it, get the Calculator Plus app from Self-Service. It's the orange, white, and black one.
this thing? Oh, do I need a pen? I do? No, I only have 4. Thank you.
All right. Was there anybody that was not here yesterday? I think everybody was here, so I think we're good. So then you can skip the first page. That was just there if I needed to somebody. So second page is where we're at. You're taking a look at these designs, and like I said, what I'm going to do is I'm going to assign you a design to work with. Okay. So this group over here, I'm going to have you do part A. You guys will do B. That group in the back, you guys will do B. Excuse me, C. Sorry. You guys will do C, D, E. You guys will do F, and I'll let you guys decide as a group which one you want. I don't care. Pick one, A through F. You guys can just discuss. Make sure you're all doing the same one, okay? But you guys can pick one. If you take a look at number 1 here, and let me actually go to that quick. Oops. If you take a look at number 1, notice it says to first analyze the pattern your team is assigned. Roughly sketch the diagrams. You don't need every little square, okay? The last class I was going through and they were drawing every single little square. You can sketch it out and just put the dimensions, okay? You can just label it as if there's 4 here or 5 there or whatever. You don't have to draw all the squares in, okay? But go ahead, I'm going to turn you loose and let you work. Again, check in with each other. Have a conversation. If you're struggling, just ask. It's okay to need help. It is perfectly fine to ask for help. Okay? Let's go ahead and go to work. I'll check in on you as you're working.
I understand. I was just finishing that up.
We know it goes up exponentially.
Sketch your diagrams, label the diagrams, put the numbers in, and the dimensions. Shade it appropriately.
What one were we? Oh.
So which are you doing now?
So
I'm not really good.
right now. It's square because it goes up and
I think roughly sketched up.
by 2 this way and this way. So what would that figure out for that equation?
Do you think it's hot?
Because I wasn't asking.
Just do what they ask on each part. Table and the graph are on the next page. Once you're starting to find perimeter and all that kind of stuff, so it's broken up for you. So just follow the directions. By the way, if you have a question, who should you ask first?
Our group.
Yeah, your team, your group. Okay, make sure you ask somebody. Again, even if it's just, hey, what did you get? I'm not quite sure myself, that kind of stuff.
Hey, what did you get?
Perfectly fine.
This is what I got. I'm very proud of my answers. Bro, the broker lunch Does it figure multiply?
This is one of those lessons too, when I was talking about yesterday, of being open to others' ideas. There's a lot of different ways to come up with answers on this lesson. So
There's 14.
you might do something completely different than somebody else in your group.
I just keep shading.
We'll just left it instead.
I'm drawing mine.
It's unnecessary. You don't have to drop on that.
It's okay. Do this. No worries.
Not judging them yet, did we draw?
Yep.
Did you do it? What'd you learn?
Best you can. I'm not worried about perfection.
Sometimes what I can do is
It doesn't have to be perfect. Yep, all the way around. Once you get to describing figure 20, looking for patterns from figures 1 through 5. So try to figure out what the patterns are and then use it to describe figure 20.
so 14. How do you sort X?
Okay?
I just keep shading as well.
Okay. Okay, start here, Jay.
No, wait, is this figure?
Okay?
No, I know how to do the equation.
Everybody doing okay? Okay, start?
Yeah.
Okay.
I don't know how to do this.
What is figure?
Because then it's going to do a graph and equation. Yep, that's exactly what we're trying to do. Nope, yeah, I wouldn't either. That takes too long.
No, AB.
Yeah, go ahead, keep going. Yep, go ahead and keep going.
Don't ask, okay?
That's all right. Yep, that's good. Yep, so just keep going.
Don't.
You're good.
Y equals AB.
Yeah, just keep working through the lesson. So if you finish that first page, move on to the second page.
Times B.
Start putting the table together for perimeter. Then you can graph it. You'll have to go through on the second page, and we put axes in there and we put little dashes. You can go through and put what they represent because it depends on which group. Some of the numbers will be bigger than others. So you can kind of label the numbers on the axes once you get there. And when you get to problem 5, they're really asking you for the equation of this problem, of the data. Okay, you're trying to come up with the equation. Yeah, you bet. What's your favorite bubble?
I like the blue one.
She's all the time. I'm trying to remember what's her favorite. She's got all kinds of them. Yep, that's great.
If 14 is in parentheses, and then this is 2.
If at some point, if your group in general has the table filled in for perimeter, not individually, but if your group is pretty much in the same spot, and you want me to come and check it, just let me know. I will come around and I'll check answers so that you know that you're on the right track before you get too far. Okay? Like I said, I want to do it as a group rather than as individuals. Hopefully the group gets the same answers.
Range between 14. No, it's right. Because 14 times 4 is, yeah, that's correct. That's definitely right.
So here's what I would suggest. You're on the right track. Fill in that table. But then you just have flipped over. Fill that in. And then look for the pattern in the table.
Perimeter.
And try to find the perimeter of each of your 5 shapes and then start to look for a pattern of those numbers. Okay. Group, we doing okay?
It's not. I am 110% sure.
Looks like that. What do we know about linear functions? Well, what you know about lines? There's one main concept every time you talk about lines in algebra 1 that came up every single time. Starts with an S.
This is X.
It's definitely not.
What do you have to?
Yeah.
Because
Because if you don't have to do
no, you have the plus.
figure plus.
It's multiplication. Wait, that's half. I think we have it.
No.
I think we might have it.
I like you. I want to run.
Is this even in the ballpark?
Let me look at these numbers here first. Which one you guys have, B?
Yeah.
Let's take a look at your numbers, make sure those are right.
Yeah, that's fine.
Five is right. We got five, right? Five, that should be 70. Let me check figure 4.
5 would be 70.
How do you get it?
Then that means this is.
The arrow?
What
This
is
is how
it?
many squares there are.
Because once you fix this, then I can kind of discuss.
For this
Go
one.
back to figure
So
4 and
it's
relook
4
at how
times 4,
you
so
do
each box is
redesign the perimeter.
And then you do.
And then for this one, it's 5 times 5. So this one has 25.
Redo if you work on figure 4.
So there's 6 times 25. So
The
6 times
shaded area.
There we go. Should be 56. Okay, so now, back to your table.
Squares, so each is 60, and that one you do 60 times 6. And then this one is 25.
Go up 14. So the question is there on the packet. If you went through and you grabbed this, would this be bigger, stretch? If it goes up by 14.
Oh, wait, no, that's just.
And what's the 14 represent? That's the slope. There it is. Now, so what you had before, was that equation right? Is that in a linear equation you were typing in?
No. I was
You had said it before, so you said it. You said it before. What? You were typing in exponential function, right? Growing exponentially, it's growing linearly.
294.
I can't figure it out. Like, I can't.
We have 294.
Oh my God.
We got 294.
You have to hold on. Hold on. Oh, never mind. Back.
You're saying if I had a
For, what you do on a table, 14, 28.
Sorry.
so hard to work in.
I don't know, I'm not even
So,
going
so
to.
the
How much about cars?
So the answer is
I think so. Oh, yeah.
It's
less work.
Okay.
What do you
How do we find linear? What do we do?
Y is equal to
Y X count around it.
Which is what I had the first.
Did you, just a picture of so we tell it.
So wait, what actually?
Yeah, then I was.
So in this case, you
Yeah,
would
I'm not.
You know what I'm gonna say?
Check the slope.
close to this.
So B would be your multiplier, so then A and then S.
And then you have that.
And then the X goes right here. We're done.
No, it's 4.
I don't even know where it is. This is X.
Let me show you what it is. Let me show
We were both wrong. I was wrong about glasses.
I don't think you guys are communicating. We're gonna build some.
Alright, what do we lost?
We were trying, we had no clue.
It starts in.
I pledge to be mature if you were Christian.
Do it more carefully. Yeah, more. 3 more there. 7. 3 more there. 10.
Yeah, raise big.
Wait,
is that yeah, you know what I'm thinking of?
They blocked that on my iPad. So when you're doing the year, but I think you come on the side.
Oh, yeah. That's so funny.
The inside of the area.
Oh.
See how is it different? So there's one there and then it's 5. So then it goes to 4 right there. So that's the 4 right there. But with
I don't remember what it's
y,
called.
which those are the figures. It looks like you just multiply all the way down next time.
Oh,
There's
there's
that. They multiply by itself.
All right, I'm going to bring you guys back together for a second. Even if you're not done, that's okay. We're going to discuss a little bit. And so if we take a look up here. I'm going to do figure A. Okay, so the group that has figure A or groups that are working on figure A. Here's what you should have found, and I'll talk to the other groups as well. Figure A, when you did the perimeter, remember you're working around the outside, just all the way around. What you should have found for perimeter for part A or group A, you should have had 12, 24, 36, 48, 60, and if you then looked at what the pattern was, what's the pattern here? It's going up by 12 every time, right? Plus 12, plus 12, plus 12, plus 12. This is A. You guys are group B. This is the numbers for A. And every group has a little bit different stuff. I shouldn't say every group. Some of them are the same. But so the pattern is we're going up by 12 every time, right? How do I get from 4 to 48? Times 12. 3 to 36? Times 12. So I don't need to go through and try to draw the 20th figure and then count all the way around, right? What can I do? Times 12. There's the pattern. So if we do that, that's 240. Okay? Now, if we then take those numbers and we put them on a graph, and we've kind of already talked about it a little bit, but so I put the numbers on here. I went by tens. You could go by something else if you wanted to. I decided to go by tens. So figure number 1, we were approximately here at 12. Figure 2, we were up here at about 24. 3 was up here at 36, somewhere in there. 4, we were up here at 48 somewhere, and 5, we were up at 60. Okay, here's the next question. What does that look like? Linear, quadratic, exponential? What do you think? Looks linear, right? How do we know it's linear? Going back to the data. The data tells you everything you need to know. It's because we're adding the same thing every time. What do we call that? We're changing by 12. We're adding 12 every single time. If you think about it being linear, it's not exponential. Exponential would be when it grows really, really quickly. Y equals mx plus b. Okay. Y equals mx plus b. What's the m? Slope is otherwise known as rate of change. How fast are things changing? And remember, slope of a line doesn't ever change. It's always the same, no matter between any 2 points. We're going up by 12, up by 12, up by 12, up by 12. That is your slope right there. Okay, that increase, that rate of change, that of increase of 12, that is the slope. Which we'll get to the equation here in just a second. Well, let's actually do it right now and then we'll talk. Y equals, we just said it's slope, y equals mx plus b, remember? So we have y equals 12x. What's my y-intercept? It's not 6. And we'll talk about y in a second. Why is it 0? Okay, yeah, if you work your way back, if you kept the pattern going, you'd be at 0. The other part, if you think about it, figure 0, there is no figure 0, wouldn't have anything in it. Okay, so it's 0. As we go through, here is your equation then that goes along with this. What if here's why this comes in handy, and we already used it for 20. What if I wanted to know, let's say the king, we talked about this before, what if the king calls and says, I want a rug that's the 100th rug in the series? What's the perimeter of the 100th rug? 1,200. 12 times 100. Now, we can make that prediction like that rather than have to go through and try to figure out the dimensions and count the blocks and all that kind of stuff. That's where I told you before, when you look at patterns, you come up with an equation, you make it work, okay? Last question I have for you with perimeter. We said this is linear, and it is because it's got a constant rate of change. Why did I not connect the dots? Why didn't I actually draw a line in? Really?
Because it's not linear.
It is linear.
Or,
The data is linear.
Because they're items, they're not in between.
Yeah, perfect. Remember, when you connect the dots, the line represents everything in between. Do we have a figure 1.5? Do we have a figure 1 3/4? No. There's a figure 1, there's a figure 2. There's nothing in between. That's why we don't bother connecting those dots. Those are called discrete data points. Okay? So then, we talked about the equation already. So then we go to the area. Okay, so go to the back side. Did anybody get data for the area? Anybody have area data? Yeah. What did you get?
For 1 it's 6.
Yep.
For 2 it's 24.
Yep.
For 3 it's 54.
Okay.
For 4 it's 96.
Yep.
For 5 it's 150.
Yep.
And for 20 it's 2,400.
All right, good. Now, this is group A again. Okay, which actually, let me go back for a second. I apologize. I forgot to tell you this. Let me go back. Group B, yours should have gone up by 14, and you should have had y equals 14x. Okay? Group C, you should have been going up by 16. Should have been 16, 32, 48, and therefore y equals 16x. Group D, your perimeter should have been the same exact one. You got the exact same numbers. It's different shape, but same numbers. Group E, you should have had the same numbers. Okay? Same number for perimeter and formula. And finally, group F, you should have had gone up by 14. 14, 28, 42, so y equals 14x. Okay? All right. Area, let me go through that real quickly. Group A, this is the right area. Okay? Those are the right areas for group A. Group B, you should have had same areas. Those are the same areas for Group B. Okay? Group C, you should have had 7, 28, 63, 112. If you had that, you're on the right pattern. Okay? Group D, you should have had same numbers. Okay? Same numbers for area. Group E, you should have had 5, 20, 100, or excuse me, 45, 80. So if you had those, that's kind of the right pattern. And then finally, last group here, you should have had 8, 32, 72, 128. That's the pattern for area that you should have had. Okay? So now if we take a look at this, we could roughly graph this. First question I have for you. Is this linear? Just looking at the data? No, why not? It's absolutely not linear. Look at the pattern. Is it a constant pattern? No, which means it's not linear. Okay? If it's not constant, it's not linear. So that means it must be either exponential or parabolic. You know, it might be quadratic, something along those lines. Okay? Could look like a parabola. And here's the idea behind this. If we go back to the patterns here for a second, let me go back to that. So here's the way that we were working before. And I was talking to Ella a little bit about this. Okay? If we look at the figure number 1, there's 6 blocks in there, right? They're all shaded kind of alternately. In figure 2, don't we still have 6? But now it's 2 by 2 squares. In figure 3, don't we still have 6? But now they're 3 by 3. Figure 4 would still have 6, but then they'd be 4 by 4.
So I just did it.
Okay? So, as you're looking at the pattern, what do they all have in common? They all have 6, right? The thing that changes is the size of those shaded blocks. 1 by 1, 2 by 2, 3 by 3, and Ella, what did we come up with?
The figure number should be squared.
2 by 2, that's figure 2. 1 by 1, figure 1. 3 by 3, figure 3. All this is the figure number squared, multiplied by itself, times 6. There's 6 of them. So if I go back, the formula that we would end up with this one turns out that it's y equals 6x squared, where x is your figure number. If you take a look at the table, let's see if it works. What's 2 squared? 4 times 6. Sure enough. What's 3 squared? 9 times 6. 54. There it is. And same thing, if I now wanted to figure out what's the area going to be of figure 100, take 100, square it, and then multiply it by 6, and you've got your answer just like that. Okay? You don't have to take all the time to do all the little pieces to get there. The whole point of this lesson, like I said, was connecting algebra to geometry and looking at patterns to try to come up so that we can make some predictions. Okay? Reminder, 113 is your practice to learn, the first worksheet of that packet I gave you yesterday. Okay? Front and back, just the first worksheet. Get that done. Take pictures of both sides and then submit that into Canvas. It does say 113 practice to learn. That is due by Tuesday. Okay? That's all I've got for you today. Have a good one, everybody.